Okay, let's finish up with the last two examples on applications of linear inequalities and systems of inequalities. So let's take a look at the information in the problem. You need to make a fence for a rectangular dog run. The length of the run can be no more than 60 feet. And you have 136 feet of fencing that you can use. What are the possible dimensions of the dog run? So first of all, let's talk about the dog run being rectangular. And if I have the length and the width, you are sure welcome to use L and W, but I'm going to let X be the length and Y be the width. The length of the run can be no more than 60 feet. And so what that means is, if this is my length, we are going to need to make sure that we keep X less than or equal to 60. Now, just kind of going ahead of myself here, what that means is, when I'm taking a look at the graph of this is the line X equals 60, I'm just going to want to stay to the left of that line. The other thing that we have to keep in mind is that I have 136 feet of fencing I can use. That means all the way around, the total can be 136. To me, that sounds an awful lot like perimeter. So the other inequality I'm going to write is 2x plus 2y, and we have to stay below 136. Okay, so I've already graphed x is less than or equal to 60. I've talked about how we're going to be shading over here. I am now going to use the intercept method to graph this equation. So I put 0 in for x, and I'm going to solve 2y then equal to 136. Divide both sides by 2. If you need a calculator to help you out, do that. So we have 0.68. Put 0 in for y. That means the y is going to go away. So 2 times 0 cancels. Once again, divide by 2, and we're again talking about 68, 0. Alright, so to graph that line, I take a look up here, and looks like I'm not quite high enough, so let's add some stuff here. Yikes. I didn't plan that out very well. Okay. 68 is right about here. And over here, 68, if this was 70, is right before that. Okay. So we've talked about before using a straight edge, which can be any flat kind of surface, including your calculator, if you want. Going to look like that. We want to stay reset to the left of that line, and using a test point we can tell 0 plus 0 is less than or equal to 136, so we're going to be staying below this line. So let's shade that region then. Talking about this triangle on down, then I want to stay to the left of this line, so it's going to be this region bounded by both the oblique line and the horizontal line. So the solution is everything that is in this region. So these points here would be the boundary of that. So two possible solutions. Really, there's a lot of things you could use, but let's say I wanted to use a 45 foot by 10 foot rectangle. or I don't know, pick one up here, a 30, a square, right? 30 by 30 would make it a square. Those would be two possibilities that would be in that region. Okay, finally, example number 4. You can work a total of no more than 41 hours each week at your 2 jobs. House cleaning pays $5 per hour, and your sales job pays $8 per hour. Let's write some things down. You need to earn at least $254 each week to pay your bills. Alright, so let's let X be the hours of house cleaning you do. And Y be the number of hours of at your sales job. Alright, so first of all, the total hours between X and Y. The total hours between X and Y can be no more than 41. So I'm going to write X plus Y is less than or equal to 41, because these are the combination of the hours of the two. In addition to that, if house cleaning pays $5 an hour, I could write 5X. And sales pays $8 an hour, I can write 8Y. And I have to make at least means 254 or more, so it's going to be this symbol. Okay. I am going to once again use the intercept method. This one's pretty easy. If you put 0 in for X, Y's got to be 41. If you put 0 in for Y, X has to be 41. Okay. One thing I forgot to do over here, I'll go back to it in a second, is label. So this would be the hours, remember the x-axis, house cleaning. And this is the hours at your sales job. Okay, so let's plot. 41 is a little bit above 40. You can see that better. Yeah, still pretty blurry. Okay, and then 41 is a little bit above 40 there as well. And I'm going to use a different straight edge for this. I'm going to connect my line. Keeping in mind, if I was doing a test point, the test point 0, 0. 0 is less than or equal to 41. So I'm going to be shading in a little while below this line. Okay. Alright. Let's do the intercept method. If I put 0 in for X, you'd be looking at 8Y equals 254. So that would mean Y is 31.75. If you put 0 in for Y, you'd be looking at 5X equals 254. 50.8 for X. So let's graph that. So here's approximately 31.75 and 50.8. Okay. So now I'm going to do that in a different color so you can clearly see which is which. This is the second one I drew, okay? Because, nope, it was this one, sorry. To 50.8. Alright, so I want to stay if I put 0, 0 in, 0 is not greater than or equal to 254. What that tells me is I'm not going to shade below the red line, but above it. So I want to stay, keep in mind, I want to stay below this green line, okay? Remember again, below the green line. And above the red line. And hopefully what you see is there's a tiny little bit of overlap. And that tiny little bit of overlap is right in here. I'm going to make it darker. That is where we have above that second line and below the first line. That would be our solution. So 2 possibilities. Let's see here. 10:30. 10 hours house cleaning. And 30 hours at sales. Or it could be any of these endpoints, like where they have in common. So you could even do, if you wanted, 40 hours of the one. So that's sales. And none house cleaning. Maybe you don't like the house cleaning. I don't know. Anyways, those are 2 possible solutions that would be in that darker shaded area. Okay, real quickly, let's go back up here. Let's keep in mind that I made X the length, so this is the length of the rectangle. I forgot to label this before, and this is the width of the rectangle. So just wanted to make sure we went back and labeled our X and Y axis for that. So that is a couple more examples of linear inequalities that are systems. So they're inequalities in more than one. Okay? And so this is something that you should refer to as you are completing the applications for 7.5 and 7.6. You should have enough information to start on that now.